All right, Unit 2 test review. Let's go through this. You can see the answers are already up here, but what I would like to do is just do a little explanations so that way when you take your test, you can get the answers correct. If you have any questions, obviously let me know. So number 1, which is not a function, that would be answer choice 4. Well, why, if we had to write out an explanation, because the x value of 0 has two y values, and in order for something to be a function, 1x has to go to 1y. The x value of 0 goes to 2y's, -2 and -1. Okay, number 2, is this a function? So does every x value get paired up with exactly one y value? So does -2 always go to 3? Yes. Does 3 always go to -6? Yes. You could say the same thing for every other point in that table, so answer choice 2 is correct. Every input, every x, has only one y. Okay, number 3, we have to be careful using parentheses, but I also recommend using your calculator if you need to. So just anytime you put in a value for, in this case, x, because f of x, so that just means x is -1, we will substitute a -1, so this just becomes -2 times -1 squared plus 5. Follow GEMS or PEMDAS, which is order of operations, to square the -1. -1 times -1 is +1. Then we multiply. -2 times 1 is -2. Add 5 to that, which gives us 3, which is also answer choice 3. All right, number 4, which graph is a function? Well, that would be the table, sorry about that, that would be the table in 2, because number 1, that's definitely not passing the vertical line test. Every x has, well, this x value, whatever it might be, has infinitely many y values, definitely not 1. Same in number 3. This x value right here actually has 1, 2 y values, not a function. And in this table, in answer choice 4, the x value of 3 has 2 y values of 7 and 1. So 2 is a function because 5 always goes to 6, 7 always goes to 7, 9 always goes to 6, and 11 always goes to 3. Question number 5, which of the following translates the graph of f of x 2 units up? So that means it needs to be on the outside, +2, and 5 units left, that would be the inside, +5. Remember, it's always the opposite, so that would give us A. Notice how the +5 is inside the parentheses and the +2 is on the outside. Question number 7 is forcing us to create a function. So take this relation and make sure that it is a function. So answer choice 3, which is the value number 4, would be the best. Well, why couldn't we use 7 or 9? Well, looks like we've already used 7 and 9 as inputs. Therefore, we can't have another input of 7 or 9 because that would mean that the x value would go to 2 y values. And obviously, 4 can't be true because we just said that 7 and 9 will not work. All right, looking at question number 7, which of the functions below has the largest maximum? Remember, maximum is the largest or the highest y value. This y value, whoa, that's pretty high. That's like almost, I don't know, it looks like 50. So that one looks like it's 50. And looking at the other y values in the table, none of these ones are even coming close to 50. Obviously, these ones are not even coming close to 50. And 9, 10, 11, and 12, none of those are getting as high as this y value here of 50. Number 8, make sure you know your parent functions. Just take a look at the answers here. Know that this is their equation and the pictures of what they would look like. And number 9, don't worry about this setup here. You know how I roll. I love to show my stuff in tables. So I created my table of values. I saw that my y's were decreasing by 7 as my x's were decreasing by 5. So change in y divided by change in x gives us 7/5. And if you're ever not sure, type it in your calculator and push enter, because a negative divided by a negative is a positive. All right, number 10. Here's a recursive formula. It told us where we begin. So we began at 1, 3. Make a table, make a table, make a table. How do I get from the next term to, or from the first term to the next one? Well, we have to use our before, now, next rules. Our now is equal to the before minus 4. And we need to stop when at f of 7. So when x is 7. So our rule, we look before, we subtract 4, and subtract 4, then subtract 4. And we keep doing this till we get to the end, so f of 7 is equal to negative 21. Number 11, here's our table. We need to figure out when x is 68, because remember, the input is always inside. So 68, our y is 150. Our in is 71, so our out is 165. C and D are going backwards. They told us our output, so we look for 180 anywhere, and I just see it here. So my input, so W was 74. And again, we want to know when our output is 140. What was our input? That was 66. Okay, number 12. The distance that Heather travels on her bike is represented by this function, where t is the number of minutes she travels. So it looks like we put in minutes because that's our x value, and we get out distance. Okay, so we input minutes, we get out distance, input minutes, that's our x, get out distance, that our y. They're asking us what domain makes sense. So what would make sense for the number of minutes? Well, we don't want negative minutes. We can certainly have 0 minutes. That just means that she wouldn't have traveled anywhere. Number 1 and 2, it's a close call. So can my time always be bigger than or equal to 0? So can we have like a minute and a half, a minute and 26 seconds? Sure can. So we can have decimals. That's why we'd actually get rid of answer choice 1. Just take a minute right now to correct your own work for A, B, C, and D. Pay close attention to what they gave you. They gave you the input of 3 A's. They gave you the input of -1 for A and C. So honestly, you could just type this chunk into your calculator as long as you are using parentheses, push enter, and it will spit out -21. Same thing in A. You could type this right in, push enter, it'll spit out an answer, it'll give you your fraction, which I would also accept as the answer. I don't know what that would be as a fraction off the top of my head, but I would accept it. B and D, on the other hand, gave you the y. So they gave you f of x. So this becomes 10. These are different. You have to actually solve. So in B and D, you're solving equations, where A and C, you're simplifying expressions. Okay, in question 14, it asks us, what is the domain? What are the x values of Paul's account? So we're looking at all of these values here. Our graph covers from this to there, since we have all of this graph going on there. So our x values are from 0 to 10, and we'll use t, but if you use x, I would have accepted this. B, we need to write this in interval notation. We need to find the range, or the y values. So from 0 all the way up to 9, 0 to 9, both included because we have closed points at both of those values, close brackets. P of 7, so that means when x is 7, or when t is 7, we have 6 as our output. And on the flip side, when our y value is 9, whoops, we'll go all the way up to 9. We had to go 8 over, so t is 8, and give an interval where the function is decreasing, so going down here or there. So you could have said 2 to 3, both with open, because remember turning points we do not include, and then from 8 to 10. I guess 10 you could go either way of having an open or closed bracket. Let's just leave them open. I would probably have accepted both. And increasing, we would go from 1 to 2 or from 6 to 8. So this could be either or. You didn't have to have both of them. Okay, so 15 is a little crazy. Let me talk you through it. I'm not going to address this just yet. Let's talk about what we did here. They gave us a function, they gave us another function, and they wanted to know what g of 6 is. So that just means whenever you see a 6 for x, or whenever you see an x, you put in a 6. So this would mean g of 6 is equal to 2 times f of 6 minus 1. So in order to figure this out, we have to figure out what f of 6 is. So f of 6 is, well, jump to this function over here, 6 divided by 3, which is 2, plus 7, which is 9. So now we know that this f of 6 is actually the number 9 in disguise. So we rewrite it, just like what we did up here. And instead of f of 6, we're putting in the number 9. And that's just multiplication, so 2 times 9 minus 1 is 17. Okay, here's number 6. We need to figure out the maximum. I actually prefer the maximum to be listed as a value, so the maximum is 5, where the minimum was negative 4. That was our y values, remember, all the way up here. And then find the values of find the values of x when g of x, so when y is equal to 0. Those are all the zeros, so here, 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 and there, negative 3, 1, 5, and 7. Find g of 0, that means put in 0. What do you get out for your y? Well, you get out negative 3. This is our y-intercept, obviously. It's where it crosses the y-axis. How many values solve g of x equals 4? So we go up 4 and we look to the left. So there's 1, 2, that looks like it's it. So 2 values. G of negative 1 means go negative 1 to the left, and we had to go down 4, so negative 4 is our output. And g of 3, go to the right 3. We had to go up 4 to touch our function. All right, more function, input, output, b of 2 when x is 2, y is 0. When x is 4, y is 2. When x is negative 5, y is negative 3. When x is negative 1, y is 1. And then backwards, when y is negative 3, so if we go to negative 3, look to the left and to the right, it's only touching at that one place. When x is negative 5, but when y is 1, whoa, holy cannoli, we actually have 1, 2. So 1, 2, 3 values, negative 1, 3, and 5 for our x's. The domain goes from, well, all the way left to all the way to the right. So what are those x values? Well, that would be from negative 6 all the way to positive 5. The range, how low can you go to how high can you go? So you can go as low as negative 4 and as high as positive 2. So we're only looking at these values for the range. The maximum is always linked to the range high point, so 2, and the minimum is negative 4. So if you ever have trouble finding the range, just find the maximum and minimum, and that way you can make the range very easily. All right, more function work in 18. So what is f of, ooh, I'm going to switch up my pointer. Look at all these fun pointers I have. Oh, you're in for a real treat. Find f of 6. Look at that bright green. I love it. Okay, so that means start at the origin, go over 6. That means we need to go, go down 1, 2, 3. So negative 3. Find all the values of x when f of x is equal to negative 1, So there's 1, there's -2, there's another, and there's another. So 2 and 4. What is a domain? So how far left does this graph go to how far right does this graph go? And we only look at the x values. That would be from -5 to 7. And some of you might say, oh, there wasn't a close point, but there wasn't an open, so we're going to assume, I guess this graph isn't the greatest. I should have had close points on these, or it should have had close points on those. But notice how it can equal. D, circle all the values that are in the domain. So can x be -4? Sure can. Can x be +3? Sure can. Can x be 5? Sure can. And how about can x be 9? No, there's no graph over there. So what is the range in interval notation? -5. How low can you go to how high can you go? Which would be this value up here. Minimum, maximum. And it says circle all the values that are in, oh, that should say, hopefully that says range on yours. If not, I'll fix it. And what do we have here? So we have -7. So can y be -7? 1, 2, 3, 4, 5. No, it can't be -7. There's no graph down here. -5, sure, because it's the minimum. 0, yep, because 0 is between -5 and 6. 7 is not between -5 and 6, and neither is 8. All right, 19. They gave us b of x right here, and we need to know what happened with this. Well, 1 unit up, and then it flips. So let's see a flipped graph. So right away I notice that all of them are flipped, and we just need to see it shifted up 1 unit. So if this flipped, that would go here, but it needs to shift up 1, so that peak, or really this dip, turns into a peak here when you reflect it and flip it over 1. Probably what I would do first is just, I would say sketch a graph of what this would look like, and then take that purple guy and, oh, will it let me shift him up? I don't know. Nope, it won't let me. But shift that purple guy up 1, and that would give us a graph of 1. All right, question 20, here we go, last page, you did it. All right, below is a graph of f of x. Describe the transformation in words, and I would actually prefer if you used the function. So in order to get from g of x to equal -f of x, you should have here f of x flipped over the x-axis. And for b, f of x moved right 3, and c, f of x moved down 2. So I'm just going to give you a minute or two just to look at the pictures. Here is our f of x. So in order to get g of x, it just flips. It's a mirror image over this x-axis. Notice how you should have the open points here, but the closed points there. Just take a minute. You might want to pause the video just to check to make sure your points are all accurate. Okay, here's 21. The height of an object that is traveling through the air is modeled below. All right, A says, what was the maximum height? There it is. And what was the maximum height after how many seconds? Well, that looks like it's halfway between 140 and 150. So 145 feet after, boom, 2 seconds. What was the object, or when the object was initially thrown? So this is at the beginning. How high was it? Well, that's our y-intercept, so 80 feet. It says write an inequality that represents how long the object was in flight from start to finish. So from 0 all the way to 5. Here, they're both closed points, so we'll have less than or equal to symbols, and yes, this is inequality notation, so we had to write it like that. Where was the object decreasing? Well, from here to there, so let's just look from here to there. It's always the x values, so from 2 to 5. Where was it increasing? So from here to there, so from here to there, 0 to 2. And just to add a little tidbit of information to help you on the test, sometimes our functions might have arrows on the ends of both. So if I ever wanted to write out, I don't know, let's say the domain of this function, how far left does this begin? Well, it starts at 0. And where does it go? Well, it keeps going and going and going. So we can write this as 0 to positive infinity. Or we could write this as 0 is less than, why am I having such a hard time writing the number 0? It keeps getting glitchy. All right, 0 is less than x is less than infinity. Or sometimes you might see it written as x is always going to be bigger than 0. Those are two of the same inequality type notations. So pay close attention to this because there may be a question on the test that involves approaching infinity, and you would have to include it either with a closed bracket or just a plain old less than because it cannot be included. Nice work. You probably got lots of points back if you watched this whole video. Good job, guys.